Okay. This will take about 15 minutes to go through. You guys can write on this. This will be your notes. Okay? And so what we're going through is the last section of chapter 12. It would be section 3. And what we're going to do is going to go through a really important concept that deals with concentration. If you were gone yesterday, the two golfers that were gone yesterday, there is a YouTube video that's posted and a worksheet that's posted with it. So you'll need to watch that with your book because there's 2 charts you're going to use. And then if there's any questions you have, come in. Okay? So that's online and you can do that on your own and then figure out what you need to do. Okay? What we're going to do is we're talking about molarity. Okay, and on top here, molarity is moles of solute over liters of solution. Okay, and a simple way to show that molarity would be capital M is the unit you can write down for molarity. Anytime you solve for molarity, you can write a capital M in its place. Or you can write moles over liters, because that's what it's equal to. Moles of solute over liters of solution. Okay? So those are all, they're not symbols like pressure, volume, temperature, they're actual units. So molarity equals moles over liters. And that's what we're going to do. So most of these, the first 2 classes I had, periods 1 and 2, they were able to solve all of these pretty much on their own with a little guidance. Okay? A lot of success. This is not that tough. All right? So, I don't expect anything different from you guys. The first one, remember, we're setting up to solve for molarity. So molarity is M is equal to MOL over liters. So what you're going to have to do is solve for the molarity. So go ahead and solve for that and see what you come up with for your answer. I'll give you a minute or so to figure that one out. That one's a pretty easy one. So on this first one, what's the answer? 2.3. All right? You have to take the 150, and then you have to, the proper way to show it, now a lot of you guys just move the decimal, but the proper way to show it would be divide by 1,000, you get 0.150 liters. So then you take 0.35 moles of NaCl. Okay, that's about 20 grams, if you would figure it, and you would put it in 150 milliliters, or 0.15 liters. And then that would give you your concentration. Okay? So the concentration is 2.3. You can do it like this, moles over liters, or you could say 2.3 capital M. They mean the same thing. If you want to shorten it up, put a capital M. If you want to show the units and see the units, so that maybe later on you can use that to convert from into liters or moles, you can do it that way, however you want to do it. Okay, the second question, what you're doing is you're solving for moles. So you got molarity is equal to moles over liters. So you're solving for MOL. So go ahead and see if you can solve for the second one. Finding moles. We need to use molarity. So on this one, you multiply both sides by liters. So molarity times liters gives you moles. So the answer for the first one is 0.088. Is that right? 87. Okay. So all you do is you take the 0.250 liters and you multiply by the molarity. Now, I'm not going to write capital M because I want to see the units divide out. So I'm going to put 0.350 moles over liters. So now I can see liters cancel because one divides into the other, and they end up with... Your units will never lie to you when you plug them in. Right. Okay, your units don't lie. If you want to see if you have the right answer, the unit should come out to be whatever unit you're solving for. So this would be 0.088 is what I have on my paper. Okay? And that would be moles of sodium nitrate. And sodium nitrate's NaNO3. Any questions on that? You have. Okay. Number 3, you have to do what the opposite of this. Well, kind of the opposite. You're going to go ahead and you're going to have to change grams to moles and then plug it into that equation. So on the third one, you're going to have to change this into moles. Then once you do that, you can find the molarity. Because molarity is moles over liters. So go ahead and do that. Magnesium's 24.305. If you don't have your periodic table, I'll tell you magnesium's 24.305. And chlorine is 35.45. Chlorine is 35.45. So those are your two weights that you would use in which to find the molar mass.
What was magnesium again?
24.305. And chlorine is 35.45. So, we take the 40 grams. You guys probably getting tired of changing things into moles, but it should be so repetitious that you don't even really think about it anymore. I'm hoping. The mass of that's 95.2. I rounded it. You guys can take it out further, that's fine. That's equal to 1 mole of MgCl2. So then you come up with an answer of 0.419. Again, you might take yours out a little bit further. You might have a little bit different number than I have. Not much, though, I would think. Then that goes into your equation, 0.419 moles of the MgCl2 divided by the liters, which is 0.250. And you got your molarity. So 1.68 molarity. And you might have came up with 1.67 or 1.69, basically based on how much you're limiting your numbers when you do the calculations. I never take off if you're off a little bit, okay? Questions on that one? Okay, number 4, you're kind of doing a reverse process and you got to find grams. Yes?
I'm not sure.
Which part aren't you sure on? Okay? Why don't you go ahead and find the next one. Okay? Solve for the next one. So in this one, you're solving for grams of NaCl. The mass of NaCl is 58.44 grams per mole. So the molar mass of NaCl is 58.44 grams per mole. Guys, I'm going to show you a little different one on these last two. Listen. I'm going to show you a little bit different approach to doing the last two. Alright? Verbally, I'm going to tell you what most of you probably did in your setup. Most of you probably took molarity times volume, and that solved for moles. And you got 0.525 moles, right? Then you took moles times 58.44. And you got your grams. It was 30.7, correct?
And this is what I'm doing. Basically, I'm putting like 5.525 moles, basically, then like 1 mole over like basically the amount. Like the amount of like grams.
Right, and that's what you do. Now, I'm going to show you a different way to approach it. And it's, listen. Okay? If you want to look up here and watch this, because what you're doing I'm going to do it all in one setup. All right? And if it makes sense, these next two, maybe you can try to do it just to see how it works for you. If it's easier to do all in one setup, maybe it's something you might want to try. All right? I'm not going to go through the method you just did, what I just described. Okay? This is what I'm going to do. I'm going to go 700 milliliters. Okay? I'm going to go ahead and say there's 1,000 milliliters in a liter. My unit's liters. Next step. Milliliters cancel out. The next step, this is my conversion ratio. 0.750 moles over 1 liter. Liters cancel out. I got moles. So I'm using this as a conversion in a setup. I'm going to keep going. For every 1 mole, I have 58.44 grams. I'm done. I don't do separate setups. Now, whatever you're comfortable with, you can use this molarity as a conversion ratio in which to get your answer. And I get my answer in grams. And it'd be the same answer as what you come up with. 30.7. Okay, does that make sense? It's something you can think about trying. This is nice because you do the calculation all the way through and you limit your answer at the very end. Sometimes if you do separate steps, you're limiting your answer as you go, and you probably don't have as good an answer when it comes to correct significant figures. Okay? But that's up to you. Try to do number 5. I've already seen some wrong answers for number 5. People have done it. And it always seems like when you guys are trying to find the value for something in the denominator of a fraction, you can't find it. Okay? I don't know what it is. I don't know, if you just haven't practiced it enough. But a lot of times when you have to solve for a variable in a fraction on the bottom, we don't get it right. You guys don't get it right. Okay? So, when you do this, be disciplined with your math, because if you're not, you're going to get it wrong. You can't guess if you multiply or divide. You got to know. So go ahead and solve for that last one and see what you get. So I'm going to show you an easy way to do this. Okay? Most of you that would do it, you would I'm going to multiply both sides by liters. That gives me liters times molarity. Okay? Equals moles. Then you do one more step, and you divide both sides by molarity. And then liters equals moles over molarity. I'm going to show you how you can use this as a conversion ratio and make it simplify it. So I'm going to go ahead and take 0.6 moles, okay, of CaCl2. Guess what I'm going to put down here? Moles of CaCl2. Okay? And up here I'm going to put liters of CaCl2. So for every 1 liter, I have 1.2 moles. Moles cancel out. I have my answer, 0.5. That's all you have to do. You don't have to do this, because when some of you do this, you never get the right answer. You don't do your math correctly. They're algebra. Doing it this way is just converting. Units work out. Okay? All right. Questions that would like you to work on. There's 5 of them. And I'll go ahead and put them up here for you to write down. Yes. What's that? Very good. You can hold on to that, and then you can use that to kind of look over for your assignment. This will be in your notes. I'll just come around and check on Monday. All right? So, I think it's page It's 902 or 904. I gotta make sure. Page 902. $341 D F. I'm going to put it in order of difficulty. 346, then 342, and then 358. I think that's order of difficulty. I could be wrong, but okay. So that's your assignment out of the book.